Alright, hello everyone, welcome back. So this is Teacher Chi Yew again, and we'll be going through the last 5 questions of 2020 paper, questions 26 to question 30. Alright, without further ado, let us begin. So let's take a look at question 26. Jenny thinks of 3 numbers. Now between them, they use the digits 1, 3, 5, 6, 7, 8 and 9, with each digit being used exactly once. Now what's the relationship between these 3 numbers? Well, the second number is 2 times the first number. And the third number is 4 times the first number. So the question is, what is the third number? So let's take a look and try get a little bit more details with regards to this question. So in this case over here, we can take a look at the few lines over here. The second number is 2 times the first number, and the third number is 4 times the first number. So what does that mean? What's the relationship between the second and third number? Well, in this case over here, this one will really mean that the third number is just 2 times the second number. Alright, I hope this one is clear over here, because the third number is 4 times the first number, which itself is just 2 times of the second number. So let's take a look and try to infer on some things, some more information from this question. In this case over here, we can take a look at this. There are a total of 7 digits. Now, a reasonable combination will be that the first number will have 2 digits. The second number will also have 2 digits. And the third number will most likely have 3 digits. Right? Because the third number is 4 times the first number. So that's a reasonable guess that we can go about with. But remember, let us look a little bit deeper at the numbers that we used. We notice that there are only 2 values over here, 2 even numbers over here, 6 and 8. And the second number is 2 times the first number. The third number is 4 times the first number. As you can tell, both of them must be even numbers. Right, because we multiply them by 2. Both of them are even. Hence, they end with 6 and 8, because each digit is being used exactly once. Now, in this case over here, what about we can zoom in on our focus to look at the second number. Now, the second number, in order for 2 digits to go to 3 digits, the tens place must be at least 5. It must be at least 5 in order to go to 3 digits. So, because say for example 50 times 2 will go to 100, and that will be the start of the 3-digit numbers. Alright, so using all this inference, we can infer what are the possible values of the second number. Now there are a few cases, so let's take a look carefully. So the second numbers can start off with 56, it's a possible number, or 58, 76, and 78. Now we will need to multiply all of them by 2 to take a look at the third number. So our teacher should write all the multiply by 2 over here. At 56 times 2, I will get 112. 58 times 2, I'll get 116. 76 times 2, I'll get 152. And 78 times 2, I'll get 156. Now something is clearly wrong here. We notice that there's a lot of contradictions, especially for numbers like 56, because 1 is repeated twice and 2 doesn't exist in our list. For 58, we got 116. In this case, 1 repeated itself twice, which is not possible. What about 76? 76 has a number 2, which is not possible. And hence, our final answer over here in this case can only be this, 78 and 156. But before writing that final answer down, it makes sense for us to do a quick check first. So we have, what about first number? If the third number is 156, the first number is equal to 156 over 4, which is equal to 39. So in this case, let's take a look and do a little bit of ticking and see whether all the digits have been used. Well, we have 1 being used, we have 3 being used, we have 5 being used, we have 6 being used, we have 7 being used, we have 8 being used, and we have 9 being used. So in this case over here, the third number must be 156. Alright, so this one requires a little bit more logical reasoning and be able to make smart guesses in order to be able to proceed on moving in this question, proceed to get the answer. So hopefully you guys have developed a little better understanding of how to tackle these kind of questions, and hopefully you guys be able to build up on your logical reasoning in order to tackle similar questions like these in the future. Alright, let's move on to question 27. So let's take a look at what question 27 is talking about. In the diagram, you enter a square labeled entry and exit at a square labeled exit. You can move horizontally and vertically along the white squares, but must stay off the colored squares. Each square can only be visited once. By moving this way and adding the numbers in the square, you pass through what is the highest sum you can get. So this one kind of gives Teacher Chi Yew that little feel of a maze game over here, that we have to try to maximize the numbers over here. We try to collect as many points as possible. So let's take a look at this drawing over here and let us draw together. So we start from the entry and we are going to travel along over here. We have no choice, we have to travel in this fashion. We'll travel towards the left and we'll travel upwards. But what's next? What can we do over here? Do we collect at 30 or do we collect at 25? Well, one thinking is that we definitely need to go in the N-shaped way. We definitely have to travel in this fashion to try and collect as many points as possible. But what's the most optimal way? Well, in this case over here, why not collect as much as we can first? Well, Teacher Chi can move to 30, proceed to 60, and collect 25 as well. But now we are kind of stuck. Teacher Chi can try to collect all the numbers over here, but Teacher Chi will be blocked. So there must be sacrifices to be. We must make a little bit of sacrifice. Either we sacrifice the 50 or we sacrifice the 55. But because we are trying to get the highest sum in this case, Teacher Chi will sacrifice the 50 and take the 55 and move on. So everything is great until we reach here. So in the same fashion, if Teacher Chi is very greedy, Teacher Chi will try to collect all these, but I'll get stuck over here. Our Teacher Chi will try to collect 150, 45, 50, 60, and 50. But Teacher Chi will get stuck because I cannot proceed back to a square that each square can only be visited once. So another sacrifice must be made. But this time round, 150 looks very, very, very tempting. 150 certainly looks very, very, very tempting. But if Teacher Chi didn't go for the 150, how would I go? I can go here instead, right? If Teacher Chi went by this way, I'll get 160 plus 45, which is 205. But if Teacher Chi went by 150 and 45, I'm going to get at most 195 value. So naturally, in order to try and tackle this, Teacher Chi will go by the other way, which will be collect all these 4 squares over here. And then moving down, it becomes really straightforward. 55, and finally towards the exit. Teacher Chi can't collect the 55 and 70, unfortunately. So the highest sum in this case would just be a sum of all the numbers. Alright, Teacher Chi will not sum it here, but the highest sum will be 585 following the path that Teacher Chi has given you. Alright, so really good job to all of you. Hopefully all of you guys are able to try to maximize these sums over here. But of course there's a little bit of sacrifices that needs to be made. You notice that we didn't collect the 150 even though it's a very big number. But overall it's a smaller number as compared if Teacher Chi moved to the other way. Alright, so without further ado, let's move on to question 28. Let's see what question 28 is about. A bale of hay can be eaten by a horse in 2 days, by a cow in 3 days, and by a sheep in 12 days. A farmer has 22 bales of hay, 1 horse, 1 cow, and 1 sheep to feed. How many days will his bales last? Those are a little bit challenging, but let us simplify this question. How much bale does the farmer need in a day? That's the question that we'd like to ask ourselves. So in this case over here, if the horse eats a bale of hay in 2 days, that would really mean that in 1 day, it has consumed half a bale of hay. Same idea goes for a cow. If a cow takes 3 days to consume a bale of hay, it's going to take 1/3 per day. Same idea goes for the sheep, which is 1/12. So by adding all these numbers up, we'll get a final value of 11/12. Now what's next? Well, Teacher Chi knows that the farmer has 22 bales of hay, and each day 11/12 of a bale of a hay is consumed. So naturally, number of days will just be equal to 22 divided by 11/12. And going by our fraction division logic, we'll convert it to multiplication, we'll reciprocate, and we'll get 24 days. Alright, so I hope everyone over here is familiar with rates, the idea of rates. It can also be applied to this kind of question. We are taking 1/, and that's our rate over here. So hopefully you guys are able to add rates together and be able to solve such problems efficiently. Alright, now let's move on to question 29. So number is autastic if all of its digits are odd. Now for example, they've given us some examples as well. 9, 57, and 313 are autastic. Now, however, we have numbers like 50 and 787, they are not autastic because 0 and 8 are even digits. Now, what's the question over here? Now, question is, how many of the numbers from 1 to 999 are autastic? Well, it looks like a difficult question initially. But if you remember what Teacher Chi said in the previous videos, you should know that whenever we ask you how many numbers from 1 to 999 or 1 to 99, it always makes sense to break down and simplify the problem by breaking up these numbers based on the number of digits that they have. So let's do that. Let's take a look at the first one over here, which is the single digits. How many numbers that have a single digits are autastic? Well, it's pretty clear. They just need to be odd numbers. 1, 3, 5, 7, 9. Well, in this case over here, we just have 5 digits. Now what about doubles in this case? What about numbers with 2 digits? We wouldn't really want to list them out, right? So in this case, we'll apply what we call the multiplication principle. So we'll draw 2 lines over here. Let's take a look at the first slot. How many numbers can the first slot accept? Well, it can accept in 1, 3, 5, 7, 9. Now what about the second slot? The second slot can also accept 1, 3, 5, 7, 9. So there are 5 numbers in the first slot, and there are 5 numbers in the second slot. So all we really have to do is to multiply them together, 5 times 5, and we get 25 numbers, which are autistic, because the tens place is an odd number, and the ones place is odd number as well. So I hope everyone can kind of see this pattern over here. So same idea goes for the triples, numbers with triple digits, 3 digits. Okay, in the same fashion, draw 3 lines. Let's identify the hundreds place. Hundreds place, get 5 spots, 5 numbers. Tens place, 5 numbers again. Ones place, 5 numbers again. So we will need to take 5 times 5 times 5, which is equal to 125. Is that it? No, right? We need to find all the numbers from 1 to 999. How many numbers are there which are autistic? So the total numbers over here will just be 5 plus 25 plus 125, which is 155. Alright, so I hope everyone finds this a little bit more easy now, especially after watching Teacher Chiw's previous videos. Remember, whenever we give Teacher Chiw asks you to find the number of numbers from 1 to 999 or 1 to 9999, you guys will be able to break them up into smaller pieces, more manageable bite-sized pieces, such as single digits, 2 digits, or 3 digits numbers, and try to find some pattern or some relationship between them. It will make your calculation much easier. Alright, now let us move to our last question for the day. So Oliver used small cubes to build a set of solid shapes as shown. The first shape, he used 1 cube. The second shape, he used 6 cubes. The third shape, he used 19 cubes. Right? How many cubes did Oliver use to build his fifth shape? Now we notice some particular pattern over here. We notice that this starts off as 1 cube from left to right. This starts off as 1 cube. It goes on to move from 1, 4, and 1 cube. And then if you guys are going to count in this fashion, it's going to start with 1, 4, 9, 4, 1. And that's the idea behind this pattern over here. Now, we notice something. All the middle numbers over here, in fact, all the numbers over here, they are all this thing called perfect squares. So you can imagine what the fourth pattern is going to look like now. The fourth pattern is going to look something along the lines of 1, 4, 9, 16, 9, 4, 1. That's the main idea. And moving on, we have 5 squared as well. The fifth pattern is going to look something like 1, 4, 9, 16, 25, 16, 9, 4, 1. And that's the fifth pattern. And that's the main idea that Teacher Chiw wants to bring you guys to. We can look at the cross section to try and tackle this question. And take a look at the number of cubes from left to right. Because it's growing in this cross section like fashion. That's why it has prompted us to look in the cross section way. But is that the end? No, right? We still need to find the number of cubes. How many cubes did Oliver use to build his fifth shape? Which is really just the sum of all these numbers. Now the sum of all these numbers is really nice. You guys can add them up. And then we get a final answer of 85. Alright, so I hope through all these exercises you have improved your pattern recognition skills. Because 1, 6, 19 doesn't look like there's some pattern to it. But instead, it looks a little bit more jumbled and it looks a little bit more erratic as compared to this particular pattern that Teacher Chiw has introduced you to. So, hopefully you guys are able to recognize patterns in a little bit more different way. Alright, So with that, we have come to the end of our AMC Middle Primary 2020 past year paper go through. Alright, and that's pretty much the end of our AMC series in Think Academy. Now, if you guys have any questions, you guys can feel free to ask me through WhatsApp, and Teacher Chi will do his best to respond to you promptly. And last but not least, wishing you all the best for your upcoming AMC exam. And hopefully you guys are able to score well. Now, if you guys have any queries or anything about the Think Academy and their long-term courses, or to me in general, or any private messages that you'd like to share with me in general, you are always welcome to contact me via the WhatsApp group as well, or my WhatsApp number. Alright, with that, we've come to the end of our go through, and hopefully to be able to see you very soon. Right? Goodbye.